Hey, this is Jay from Hurgle Studios, and today we're going to walk through how to do a King-Knight Sudoku puzzle. So, you may notice the clues are a lot more sparse than they are in other puzzles, and that can be a little bit unnerving, but the area of influence that each clue has is so much larger that it makes a huge difference. As usual, we'll start by filling in all of the cells on our grid with the appropriate hints, and then removing them one cell at a time for everything that's been given as a clue. First quick pass we'll make is to scan through the grid for any singles where there's only one possibility in the grid and fill in all of those. We've got a 2, a 5, and a 7 there. And it looks like that's all the singles we have. This 4 has such a large area of influence that the 4 in this square can only be in the bottom row. And that means we can remove all of these other 4s. Same with this 6. There can only be a 6 in the top, so we can take a 6 out of all of these cells. What else can we find given what we started with? This 5 means that a 5 has to be in the top row here. This 5 at the bottom right rules out the top left square. The only possibility for a 5 in the top right square is this highlighted cell at the top left. So we'll fill that in. This 7 and the 7 in the square below mean that the 7 in the bottommost square has to be on the right side. But the area of influence here rules out this purple cell under the 5. The 7 has to be in the bottom row in this square. In this bottom square, there are only 2 possible places we could have a 1, and they're aligned in the same row. So we'll remove all the other 1s from that row. What can we gather from this 8? This 8 and this 8 mean that the 8 in the center square has to be in the top row. Let's see where those overlap. None of these squares can have an 8 because they're all seen by the squares below that are the only possibilities for an 8. So we can remove the 8 from those. Once we do that, we'll notice in this row the only remaining possibility for an 8 is this cell here. So we'll fill that one in. When we do that, it eliminates 2 of the top row possibilities from the center square, meaning that the 8 has to fall in this third one. While we're in this row, we have some 1, 3, 4, 7, 9s, we have some 3, 6, 9s, but we only have one square where a 2 is a possibility. So we'll fill in the 2 there out of necessity. These 2 squares are now the only ones that can contain a 6 over here on the right edge. And they both have view of this 1, 6, 9 square. It can't be a 6. Same with the 4s here at the bottom. These are the only 2 that can have a 4, and they both have sight of this 3, 4, 8. So we'll remove the 4 from there. Now I see, looking across this bottom row, there's only one possibility for a 2 in this row, and it's there. We'll put in our 2 here and see where it's narrowed us down. These are the only squares that can contain a 2 in this bottom box. Is there anything else readily apparent that I'm overlooking? 1, 3, 5, 6, 9. There are 4s over here. Is there anything containing a 6 that's overlapped by all 3 of these? Because the 6 has to be in one of these squares. These 2 definitely do overlap, so I'll remove the 6 from those. How about with 1s? The only 1s in this box are in this column. They overlap this square, and they also, because they are in a column, mean that there can't be a 1 in any of those positions. See, 7s. What can we take away from the only spots that have 7s in here? These 3 squares are all seen by the 7s, so we can take the 7s out of there. These 4 in the center are the only ones that have 4s. Which means these 2 squares, which are seen by all of them, cannot have a 4. There are a lot of 5s here, so I don't know that we'll pull much useful information from that. 6s as well, there are quite a few. How about in this column? This 7 means that none of those squares can have a 7. This takes care of those. This takes care of the bottom one. The only cell in this column that can have a 7 is here. So we'll put that in. That narrows our 7 down to the top here. Ooh, I see a set in the top right. We have a 1, 2, 6, 9 partnership. Those 4 cells have to contain a 1, a 2, a 6, and a 9. They're the only ones that can, leaving that cell as a lonesome 8 since it can't be a 1. That gives us a lonesome 1 at the bottom here since it's no longer an 8. We have a 1, 2, 6, not quite. These 2 squares have to contain a 4, but it looks like we've already cleared out the points of overlap for those. Although, these 3 squares have to contain an 8. There's no 8 anywhere else. Where do these overlap? At this center square, so it cannot be an 8. And in this row across, the only 2 cells that can have an 8 are these 2. Where did they overlap? Well, they both see these two cells, so those cannot be an 8. So we have the 8 narrowed down to this column at the bottom, with the 8 somewhere in this column and this 8 on the right. The only spot we can have an 8 in the top block is in the center. And there we are. It's the only cell that can be an 8, so we'll go ahead and fill that in. That gives us great headway into our 8s. These two mean that the 8 in the bottom left square has to be in the center, and this blocks off the top 2 of the center. So we know that the bottom center there has to be an 8. This means in the bottom middle here, one of those 4 has to be the 8, and there's only one that's not ruled out by these 2 at the top. We'll fill in that 8, which means the only spot left for an 8 in the bottom right corner is here. When we fill that in, we've completed our 8s and given ourselves a lonesome 3 to work with. We'll fill in that 3 and see what that affords us. We now have a 4-9 pair here, which means none of these other cells can be a 4 or a 9, which gives us a lonesome 5, which in turn gives us a 6. We then have this 1-3 pair here, which means none of those cells can be a 3, and none of these cells can be a 1 or a 3. Does this 4-9 pair tell us anything else? It does. It tells us there's no other 4s or 9s in the rest of this square. That means this must be a 6 and this must be a 3 accordingly. We have a 1, 4, 7, 9 set here, which means that can't be a 1, a 4, a 7, or a 9, forcing it to be a 2. That gives us a revealed 4, which lets us start wandering down the chain of filling out the singles as they're revealed. We have a 2 up here, a 1, that gives us this 3, that 7, this 9, and this 1, giving us a 5, a 3, and a 4 at the bottom. A lonesome 1 gives us this 2, and this 6 and 7 give us this 3 and 9 that give us the 5 and 4 respectively. 1, 5, 6, 3, 4, 7, 9, 4, 9, 3, 5, 1, 6, 7. And the puzzle basically solves itself after you get to that point, as long as you're remembering to track those possibilities. And just that easy. We're done with our King Knight puzzle for the day. Hope this strategy has been helpful, and we look forward to seeing you on the site.